Hey folks, welcome to Build, and especially welcome to this session on simplifying .NET installs with .NET. I'm Chet Husk, and I've been working on the .NET SDK for a few years now, and I'm excited to show you this new product we've been working on and show you how it might help tackle some problems that you have been facing managing .NET itself. Before we really get into things, I want to take a few minutes to let you know what we're going to be looking at today. So first, I want to sort of shape the problem for you and let you see how I see getting .NET on your machine and managing versions over time. And then I want to briefly sketch out the outline of our plan on how we'd like to solve this. And then we'll get right into the meat of some demos of what's coming in our initial preview versions of .NET Up. Finally, we'll come back and we'll talk about what's on the roadmap for .NET Up and when you can expect to see and use it and get hands-on yourself. Okay, are you ready? Let's take a look at what we're dealing with here. So if you install .NET today, we think you fall into basically one of two buckets. You are either using Visual Studio on Windows, where Visual Studio manages the toolchain for you and updates on a frequent cadence and brings you all of those feature band and servicing bug fixes that you know and love, or you're everyone else. And that's exactly the problem that we'd like to solve. If you look at installing .NET on different platforms, it's a very, shall we say, heterogeneous situation. Here's a short list of a bunch of the different ways that you can install .NET today. Uh, if you sort of break these into categories, what you have is IDE-based distribution, you have package manager-based distribution, and then you have manual distribution of various kinds. For IDE-based distributions, on Windows, you have primarily Visual Studio, and then across platform, you have Visual Studio Code, where my team owns a Visual Studio Code extension whose job is to get you the SDK versions that your projects and tools need to run. Outside of the IDEs, you have package managers, things like WinGet or Homebrew on macOS or Linux, and we'll get there in just a second. And these tools use the systems capabilities to acquire .NET packages. These are really nice for a number of reasons, the most interesting of which is the kind of centralized management you get. But for some people, that model is not a good fit. And so they reach for more manual ways of installing macOS. Some of the most common of these include the actual .NET website, which is get.net, which is one of my favorite things to say. We have a set of install scripts for PowerShell and various POSIX shells that people often use to manage their CLI and SDK installations. And then there's a whole ecosystem of tools that exist specifically to manage versions of various software development tool chains. For .NET, there's a community project named DNVM or .NET Version Manager, but there are also more extensible or pluggable systems for this, like mise-en-place or ASDF. There are too many to count here, but these are some of the most familiar or most frequently used. I haven't talked about Linux yet, though, but I do want to point out that all of the mechanisms here on this slide that you see with an asterisk are not mechanisms that are owned and operated by Microsoft. These are community mechanisms in a bunch of different ways. And sometimes they use packages under the hood, and sometimes they use just zips or tarballs. And in some cases, like Homebrew, they can use both depending on your preferences. So already you can see it's a very mixed bag of ways to get .NET and the sort of pros and cons of each mechanism. And we're about to get even more complex as we enter the world of Linux distributions. You have a bunch of different ways, those sort of same three categories of package managers, the .NET install scripts, and then the sort of manual installation tools. But this is coupled with the fact that for the package managers, there's been this long arc of history where sometimes Microsoft provided packages for your package manager, and sometimes your distro provided packages for your package manager, and sometimes you had both. So there's a long list of sort of decision trees that you have to go through just to install our software. You have to decide if you're okay with certain restrictions on the feature bands that you will have available to you, because the .NET SDK ships 4 times a year, and each quarterly shipment contains net new features and enhancements. Um, so, do you want those, or do you want the sort of centralized update mechanism that the distro's package manager will give you? Do you need different versions across your different repos? If so, the package managers may not be a good fit for that. So it's pretty easy to, as you start looking at the needs of your individual repos or your individual developers, that you find that the happy path of package managers doesn't work for you, and you start having to reach for these sort of local management solutions like .NET Install or DNVM, Mise en Place, etc. These tools are great. They do the job, but in the case of the install scripts, there's no sort of central management. So you can keep track of what SDKs and tool chains are installed where on your system. There's no way to easily update individual installations or all of the installations on your system. And in addition, often these local mechanisms tend to clash with any global or system level installs. And all of these statements are true even on other platforms than Linux, right? So there's this very complex installation problem that users have to solve. And then when you guys find bugs or gaps in our software and you want us to consider making enhancements or fixing those bugs, it's difficult on our end to categorize how that installation occurred and validate that that installation is correct in the first place. So there's pain on both ends, believe me on that. So, what do we as a tooling team want to do to solve this big problem? Well, there's all those different installation mechanisms, and we discovered we would make another one. And this is the one that'll solve all the problems. And I'm only half joking here. We'll take a look in a little bit more detail in a moment and sort of see how we plan on tackling some of these problems. Um, but I could not resist the opportunity to call out to Randall Munroe's comic here. Our plan for solving this platform specific and sort of managed versus unmanaged split is to make a tool that behaves the same on every platform and that leans into global installations that do not require user elevation. So in this case, when we say global, we don't mean system global, we mean user global. Installations of .NET that are scoped to your user directory or a location where you specifically manage, and that don't impact others on your system. So we want to make this tool and make it fast, make it lightweight, use native AOT to make it execute as quickly as possible and get out of your way. We want it to leverage the existing mechanisms that users use to describe what SDKs and tools you want. Today, that's global.json. But the hope is that with a sort of shared way of interacting with SDK installs, we could potentially evolve that file format or its purpose into something more ergonomic. Along the way, we want this tool to cover features and functionality gaps that system level install users have that user level installs do not. So earlier, when we were talking about some of the pros and cons of the installation methods, I mentioned that package managers and installers, like the ones that Visual Studio use, have central management and auditability kind of baked in. And the current mechanisms for user level installs don't. So we want our tool to bring that level of audibility and safety to everyone. And so to enable this, we've been working with the .NET releases teams to sign all of the binaries and all of the manifests involved so that you know that the binaries that you are using are the ones that we intended to deliver to you. and all the way down. And then finally, we didn't want this tool to exist in isolation, to be in a bubble. We wanted to create this tool and create a library around it so that other tools that needed to behave similarly or that needed to interact with installs had the option of using a library that would do things correctly and safely. So this will play a little bit more into the long-term plans, but we hope that if this tool takes off, the manifests and bookkeeping that it uses become a shared resource for a constellation of tools like Dependabot and Renovate and this whole sort of auditability and automated compliance infrastructure that many developers use today for their package references and their Docker file references. So we want to fit in that world. And part of fitting in that world is providing tools to plug in easily into those systems. So from this point on, we're going to talk about some of the specifics of .NET Up and show it to you. But I want to be super clear. Everything you're seeing from here on is like internal preview level. We'll talk about some of the milestones in this release process a little bit later on, but I wanted to show you what we have today so you can sort of see the vision of how it all works together and so that you can sort of see where we're aiming for and give us feedback because the earlier we get your feedback, the earlier we can incorporate it and the better the end product will be. So, big giant under construction label here. If this were like the early 2000s and a web page, you'd see the big blinking marquee under construction sign going. So just be aware of that. We're going to lean into some demos now, and I'm sure the first question on your mind is, how do I get this thing? So we're going to talk about the acquisition and initialization of .NET Up on different systems. Then we're going to show how you can use .NET Up to easily get started in a couple of different kinds of repo shapes. And then finally, we'll talk about how you can use .NET Up to tackle one of the more annoying problems of toolchain management today. So let's get into it. I'm going to Alt-Tab over to my terminal here. And where we are is in a repo that I'll give you the link to a little bit later. I've got a repo where I've put together some scenarios, some example repository patterns that might benefit from .NET Up. So if we look in my scenarios folder, I've got 3 scenarios here: a cross-platform web app, a multi-runtime testing application, and then an application that has up-to-date or outdated .NET SDK installations. I want to start with the most straightforward one, but first I need to get .NET Up. And that's where we've tried to make this really easy. We have aka.ms links that I will again show a little bit later to make it easy to get .NET Up. You can go to aka.ms, .NET Up, get .NET Up, and there will be a shell or PowerShell script that you can use. And we'll have examples for both of these in the documentation links that you'll see later. But it's as easy as running this script. And this script is going to look at the platform you're on and determine which version of .NET Up it should go download. Because remember, this is an AOT platform-specific application. We want this to be as fast as possible. We will download it, verify it, and then install it into your home directory by default, though, as always, you have 100% control over where this thing goes. So path isn't configured because that's a little hard to do in a script that you source like this on Linux. So we'll just start by invoking it manually. And the first time you run .NET Up, or when you run the init command specifically, you'll get run through a sort of configuration walkthrough where .NET Up itself will help you set your system up for success. So I just want to call out here that .NET Up, like the .NET CLI, collects usage telemetry to help us understand how you use it. But just like the .NET CLI, you can use all of the existing telemetry opt-out flags that we have in the .NET CLI to control that experience. So just a heads up there. The first time you run .NET Up, like I said, you'll get this walkthrough, and it wants to ensure that you are set up with a viable installation of .NET that you can use to start development. It's going to prompt you for the different channels that you might want to use. And because I'm a bleeding edge kind of person, I'm going to choose latest so that we will get the latest stable release that exists today, and then we will stay up to date over time. The next question is how you'd like to use .NET Up. This is a little bit of it could be a bit of a deep dive, but the way that matches most closely to how you might be expecting this to work from tools like DNVM or 𝗦𝗫 is terminal mode. So I'm going to use this. And in this mode, .NET Up is going to configure itself to add itself to the path and to add the .NET installation location that it manages to the path. And I'm going to skip that last question because .NET Up saw that I had global installs and offered to sort of port them over to the new world for me. But when I told it what to install, it went to go grab it. It went to go install it into its managed .NET installation location. And then it gave me some nice UI and UX around the downloading and installation of that SDK. So at this point, it has downloaded the latest .NET SDK for me, and it has updated my shell profile so that on subsequent invocations, my shell will include all of the environment variables and configuration necessary to successfully run .NET Up. So if we go look at the command that it inserted into my profile, this is a shell-specific script. It detected I'm using Z shell that sets up .NET to use the installation that .NET Up manages, and then ensures that .NET Up and the .NET .exe are on my path, which is great. That means I can now do .NET Up info. Well, if I were in a new shell session, I could do that. So I can do .NET Up info here, and I can see that I'm on a specific version of .NET Up, and then I can do .NET info as well. And because this is the first time that version that is run, it will do some crunching, and then it will tell me everything about this installation, which, as we figured out was, or as we asked for, is 10.0300, is on Mac OS, is installed to a location that .NET Up manages, and comes with the ASP.NET and .NET Core runtimes. So this is exactly what anyone coming to .NET would need, and it was as easy as .NET Up init, and we're good. So now that I have .NET Up, I'm prepared to work on any repo that I want. So if we go into the cross-platform web app that I wanted to show you all, this web app is very simple. It has a library and a web app that consumes that library, but it also has a global.json file that I want to show you. And this global.json has something different to what I just installed. This global.json says that this repo expects to use 10.0100 of the .NET SDK. Why? I don't know, but this is what the developer has chosen. But it's okay with rolling forward to the latest feature bands. So we're gonna use that. And it turns out .NET Up understands that. So if we run .NET Up, if we run .NET Up SDK install here, yeah. Oh, it rolled forward to the latest feature band because that's what's in the global.json. So, but if we open up in our global.json in VS Code here, and we change this to be something like, we'll do latest patch instead, and then we come back to run our install, then we can see that .NET Up has chosen to install 1XX, so meaning the 100 feature band. And it even tells us why, because the global.json in our project specifies that version. And so here we can also see the download and the install of this new version of the .NET SDK, and we're good. So now that we are in our repo, we can go run our web app or build it, and everything will just work. It'll use the SDK that we told it to, and it will build the app, and I didn't have to do anything crazy. All I had to do was run .NET Up install or .NET Up SDK install. And with that one command, I was good to go. This is the core sort of value proposition that we see. And so here's me proving that we use the 108 SDK. This is the core value proposition of .NET Up. You could do that same gesture, grabbing the .NET Up installation, running .NET Up init to get a .NET Up install going, and then .NET Up install on any repo and have a .NET SDK that will work for that repo. That's great. Like, it is very frustrating to have to manage those things today. And while there are some helpers that will use a global JSON in CI/CD, for example, like in GitHub Actions, the actions setup.net action will do that for you. There's been nothing supported locally that you could use on your developer box or that an agent could use on your behalf. So we're trying to fill that need here in a supported way. .NET Up does more than just SDK installations, though. If you list this, if you run the .NET Up list command, you can see that it's actually tracking those decisions that you've made and why you've made them. So it knows that it has two versions of the .NET SDK installed, and it knows what channels you are tracking. So it's tracking the latest channel because I explicitly told it to on that sort of startup. It's tracking the 1xx channel because our web app global JSON told it to. And that's good because it means that when a new 109 is released in May or a 110 in June and so on, I guess 108 was May, so a 109 in June and a 110 in July and so forth, .NET Up will understand that, and a .NET Up update will do those updates for you. So this is the real beauty. It's not just installations, it's understanding what you need and what you have and what is available and making those things all align consistently. So that's kind of the first end-to-end example I wanted to show you. And this is something that if you are engaged in open source or if you are using agents to help contribute to open source repos that you use at work or whatever your pattern is, that's a pattern you probably had to do before. You had to go clone the repo and then figure out, like, you just try a normal .NET build and the builds or the SDKs you have don't match with what's in the repo. So that problem we can say is solved definitively. The next scenario is a little more interesting and I think shows off more of the potential future direction for .NET Up. And for this one, I'm going to need to show you a little bit of code to sort of set it up. So we have a repo here, a workspace, where we have a source code library that provides some utility that we care about. And then we have a test project that consumes it. So we have a really cool truncation string helper here and a string helper that can check if a given string is only alphanumeric ASCII characters, right? So kind of basic stuff. And like, responsible developers, we've created a set of test cases for it. And so we want to be able to test this. Well, what's interesting is that, like many library authors, we might want to do some customization of that library for different target frameworks. For example, in .NET 10, maybe there is a new span-based overload of index of string that we want to make use of that we can't on .NET 8. And so in our library, we might have an if-def that we add in here that we use a different execution path on 10 versus 8. But we still want to build for 8 because we want people that are on 8 to be able to use our library. We call this multi-targeting. And from a library perspective, it doesn't actually matter what you target here. So here in my library, I'm using Net Standard 2.0 because my library doesn't do any like per runtime specialization. But as a library author, I want to make sure that everyone on the latest and greatest versions of .NET can use my library. And so a way we could do that is by making sample projects that consume my library and use it. But a more integrated way is to write tests And so that's what we've done here. We have a test library that targets these 3 different in-support runtimes and just has these tests, right? Something I've struggled with often in my career is I want to use the latest .NET runtime, or sorry, the latest .NET SDK, because the SDK is where all the tooling features come from. So regardless of what runtime I'm building assets for, I want to use a 10 SDK right now because that's the latest major version out there. So I end up in a situation where I have one SDK, but I need multiple runtimes to run my tests. And if I try this right now and I come over to my test and I try and run, well, before we get into this, I'm going to go list runtimes. And you can see here that we just have 10 runtimes. And I'm going to run .NET test on my tests, which target 8, 9, and 10. And that took no time at all to run, but it didn't run successfully. I'm going to zoom out a little bit so you can see it. But what happened was on .NET 8, no tests ran because we did not have a .NET Core runtime for version 8. And then for .NET 9, no tests ran because we did not have a .NET Core runtime for 9. And then on .NET 10, our tests did run and they passed. This is something I see all the time. And when people see this, the way they fix it is in their CI/CD providers, they install entirely parallel SDK installations, right? So if you ran this command on their CI setups, you would see an 8 SDK, a 9 SDK, and one or more 10 SDKs. And to me, that's not necessary because new SDKs include new tooling and fully support building older runtimes. So instead, what I would like to do is just be able to get runtimes that I need to actually run my application. And this is not something that you can do easily today. So one of the things that .NET Up kind of makes easy is installing runtimes. And so I've done a little shenanigans here and I've made a fake extension to global.json where I can say, I need some runtimes and I want the .NET runtime and I need 8, 9, and 10. This syntax is not final by any means. This is just something that might happen in the future. And there's a world where .NET Up would understand that and it would, when you ran .NET Up install, it would do that for you. It would install both the SDKs and the runtimes that you need. We're not in that world today. And so instead, what you can do is you can do .NET runtime install 8, 9, and 10, and it will do them all at the same time. It'll go find the latest ones of each of those bands, download them, and install them. In this case, I just said 8.0, 9.0, and 10.0, and .NET Up got me the latest one of each of those bands. If I had specific needs, I could say specific versions. That's not a problem. But it's very easy now to acquire these runtimes. And now that I have these runtimes, I can go run my tests again and they'll work. And I didn't have to install entire new SDKs at hundreds of megabytes apiece just to make my tests run. This to me is the best of both worlds. You're on the latest tooling, but you're able to do the things that you need to do in ways that you couldn't before easily. So this is exciting to me. It's bringing some of the convenience of things that you could do in your CI/CD setups to your local development. So that's another example of the kinds of functionality that .NET Up can provide. And even though I'm just showing the .NET runtime here, you can specify all kinds of different specifiers here. You can do ASP.NET and you can do, yeah, so like here's an example of ASP.NET Core. You can also do Windows Desktop on Windows in that case. So that would look like .NET Up, runtime, install ASP.NET Core at 8.0, right? And this pattern of component name at version is one that we've been sort of fleshing out over a few SDK releases here. And now we have that runtime. So if we run .NET list runtimes now, you'll see that we have the core runtimes for 8, 9, and 10, and the ASP.NET runtimes for 8 and 10. Easy peasy. That's it. So that's like the core value prop. Can I get tooling more easily? But it's also interesting to note that getting the tooling is only half the battle. There is a long tail of maintenance and upgrades that responsible development teams have to adhere to. And .NET makes that possible as well. So we saw .NET lists before, but I just want to call that out here again to note that like those explicit runtimes are also tracked here. And you can see what is currently installed, and you can see the requests here as well. So when new versions of the runtimes release, a simple .NET update will cover them as well. And because I just installed all of these, they're all already up to date. But if any one of these were out of date compared to the requests that we had, .NET would have installed them right there. This is all happening under the covers because .NET is keeping a manifest, an installation tracker in your user directory in a data directory there. So that's kind of, you can think of it as like a lock file for the declared or desired state of your system. It's not necessarily something that we intend to share across repos or across developers. You should still use global.json to describe your like requirements for development, but that manifest is what's powering a lot of this update information as well. So those are some of the core functionalities there. There are a few other interesting things about .NET that I want to call out here. The print m script is a helper command that can be used to make sure your shell is configured correctly to just natively use .NET. This is what is used when you do that init to configure your system to use .NET. Right now, this print m script is supported for Bash and Zesh and other sort of POSIX shells only. PowerShell support is coming. We have that in PR. And hopefully within a week or two from the time that you're seeing this, you'll be able to grab .NET yourself and give that a try. The other thing that's interesting that has been missing from SDK management is uninstallations. So when you do these updates, new versions of SDKs and runtimes will be installed on your system, but that means the old ones may not actually be needed by any tools anymore. So an update will remove out-of-date installations that are no longer needed by the set of requirements that you have declared. You can also manually uninstall SDKs and runtimes if you need them. Architecturally, I want to call out here that .NET has sort of a top-level install, update, and uninstall command, but it also has component-level commands. .NET SDK install, .NET SDK update, and so forth. This is because we are seeing .NET as a way to start thinking about the entire .NET toolchain in terms of components. Right now, the two like clean lines we have for components are SDKs and runtimes, but there are features and functionality of the SDK that might make more sense as discrete components for you to use. Those of you who are familiar with tools like RustUp may see where this is going. You can imagine a world where pieces of the SDK might be able to release at different cadences. And instead of drowning in a bunch of different update notifications and inability to control that rate of change, you as a developer could use .NET to stay on top of that and have one command to manage all of your updates and components. So that's where I think we'll stop with the demos themselves, and we'll switch back over to go talk a little bit more about what the future of .NET will look like. And to talk about sort of future development, first I want to talk about who we're designing this for. There are two primary consumers here. The first is humans, and the second is agents of all kinds. Not just the AI or LLM style of agent, but CI/CD systems are agents in a way as well. So really it's humans and automated use cases. we want humans to be able to use this tool, and we want their expectations from other ecosystems to carry over broadly. We want to fill a need for uh, simple management and consistent management of the parts of our platform. We don't want someone to have to learn a bunch of new concepts. We want them to just be able to clone a repo, run .NET up install, and be good to go, right? And we want that user experience to be something that someone on any OS platform can use. So this entire time I've been talking about users using this. I'm meaning developers specifically, right? This is a developer time tool to make developer time use cases more simple and easy and straightforward. For your production use cases, you would still want to use your package manager to grab like .NET Runtimes for your framework-dependent applications, or you'd want to bundle self-contained if that's the deployment mechanism you prefer. Both of those are better options for production deployments because with package manager packages, you can get cross-system-wide security updates as soon as they're available, right? Those of you doing self-contained deployments already know that you have to be on the ball every month for security releases to roll out new versions. So production is not what we're talking about with this tool. We're talking about developer time use cases for humans. Agents similarly bring expectations. In their case, their expectations are a combination of what they were trained on and what the skills and context they've been given say. And so we want agents to have something that looks and feels similar to other tools, but adapts itself a little bit more cleanly to some of the specific needs of our ecosystems. So we want to give it a tool that the agent can use successfully, quickly, and importantly, so that it can do setup and management the right way. Because it's very possible for an agent to go look at some docs and get half the story and unzip a zip install on your system in a way that negatively impacts your development experience. So we hope this tool can provide guardrails for those agents in a way that sort of ad hoc downloading and execution wouldn't do. Agents also tend to work best without admin rights, right? In sandboxes with guardrails. And so we needed a tool that would work outside of a user elevation context, which then sort of leads naturally towards using your user directory in this way. Both of these categories of agents need to stay up to date to get security fixes and tooling enhancements, and they need to be able to exercise better control over their environments. They need to be able to say semantically, I want whatever the latest stable version is, or I have a constraint that says I need to stay on the latest 10 series of tools, right? So we want to be able for you, we want you to be able to express those constraints and then have tooling respect them locally the same way that CI/CD tooling respects them today. So I've shown some things that it can do today. I want to look a little bit more towards the future as we get closer to internal and public preview and beyond milestones. What I showed today was management of stable SDKs and sort of manual management of runtimes, right? The runtime installations, you didn't have a global.json way of dealing with that. So you had to explicitly say, I need this version. So we want to, in internal preview, focus on managing SDKs. And we have a PR in the pipeline that will even let you manage daily SDKs. So those of you who are sort of bleeding edge may know that we have these monthly previews of the next major version of .NET. So this month we released .NET 11 Preview 5, for example, or I guess 4 actually. We're working on 5 right now. Those previews, we consider them like stable from like a release management process perspective, right? Separately from those previews, every build that goes into the .NET Unified Build System produces a workable, usable SDK. And those can sometimes provide bug fixes or sometimes provide new features and functionality that we would like fast feedback on. And so one of the things that we want the internal preview to enable you to do is to try that out, right? We would like you to be able to say in your global.json or at the command line, hey, give me the 11 nightlies. Give me the hot builds for 11 and just let me have a way to try those out easily. But we also want to give you a way to sort of easily A/B compare behaviors. And so I call this one-shot execution. We want there to be a command called .netup.net that you can use to specify a specific version of .NET to run a given command on, right? So in your case, it may be as simple as .NET build, but you want to validate that .NET build on 10.0300 works the same for you that .NET build on 11 preview 5 does. With this one-shot execution, you could specifically say, hey, .NET up, run .NET build on 10.0300, and then run .NET build on 11 preview 5, and you could compare and contrast those experiences. Maybe there's a UX change to the way that the MS Build terminal logger shows things that you need to react to, or maybe there's a behavioral change in the SDK targets, or maybe there's just a CLI tool that is tweaked that you want to try out a bug fix on. One-shot execution should make it easier for you to A/B test and do so in a way that doesn't impact your global installation. So I'm very excited for that, for people to try sort of ad hoc fixes and give us even faster feedback. So all of that is sort of internal preview, daily builds, one-shot execution, stable SDKs. The next milestone that we're aiming for is public preview. In this milestone, it's more about helping you stay compliant. The public preview will have the ability for .NET Up itself to update itself, right? Those of you who have used the Aspire CLI have seen how useful this can be in practice. But .NET Up, once installed, should be able to just take control of its own updating from there with all appropriate signing and validation there. In addition, we want .NET Up to be able to give you update checks and notifications as well. Some of those of you who've used tools like 𝗦𝗲𝗀𝗀𝗶cie or 𝗦𝗲𝗀𝗀𝗀𝗁, when you start up a terminal, when you're using these tools, once a day or once a week, they do a check to see if there's a new version and then let you know. We want to do the same both for .NET Up as well as your installed SDKs, so that you know when there are security updates or feature updates and you can hop on board those trains and take advantage of them as soon as possible. Public preview will also have full signature verification of all stable releases of both the .NET SDK and Runtime tooling as well as .NET Up itself. Again, for that provenance stuff I mentioned earlier on. When you use this tool, we want you to be confident that you are using like the bits that Microsoft intended for you to use here. It's about safety, security, and managing your supply chain in that way. For public preview, I'd also like us to have agent skills available and published to the .NET/skills repo, so that those of you who are using LLMs to do automated updates or do A/B testing, compare and contrast between versions, can have good ways of using .NET Up easily without having to write a bunch of skills and context yourself. For GA, we want to focus on fit and finish of the tool itself, official docs up on the .NET website, mentioning and supporting .NET Up as an official install method on the .NET website itself, and also expanding the usage of global.json to manage those runtimes, that sort of hypothetical I showed earlier. In the far future, .NET Up, I hope, is a vehicle for us to radically change the way we ship the SDK and enable faster updates of all of our tooling. I don't know if you've noticed, but with AI and LLMs exploding the way they have, there's a push to release earlier and more often and more incrementally, right? The way you manage risk is by broad testing and like faster rollout, so that if there is a problem, you can react to it faster. We want that for not just .NET Up, but the entire .NET tool chain. But it can be hard to do with some of these delivery mechanisms that I've talked about earlier. We think .NET Up can help us accelerate our delivery, as well as help factor out the SDK itself into components that may be able to update more rapidly through those traditional channels. We also want to focus longer term on integrating .NET Up into the existing CI/CD integrations that you use to manage .NET today. Actions/setup.net for GitHub Actions and the use.NET 2 action on Azure DevOps are great tools to have, but their features subtly differ sometimes, and they may not have all of the same capabilities. They may not be necessarily investing in the same amount of caching or performance. We are hopeful that by using .NET as the implementation of those tools, that we can bring consistency of experience and a single place to improve performance across environments there as well. So that's a brief glimpse into the roadmap. Timeline-wise, we hope to have an internal preview in the next couple weeks and public preview before the end of the summer, ideally. This tool, .NET is not locked to the .NET SDK ship cycle or timeframe. It ships what we call out of band. And so with it, all of these gates are going to be based both on like feature functionality as well as feedback that you give us about its quality and usefulness. So like the more feedback you can give us trying this stuff out and kicking the tires, even on these internal nightly bits, the better. Which leads us into sort of what I'd like you to do now that you've sat through this whole talk with me. The first thing I'd like you to do is to get .NET Up itself. Here are those aka MS links that you can use to easily get started. I'd start on the docs link here. So aka ms.netup/docs. That is a getting started doc that will give you the exact like copy paste shell script snippet that you can use. For the shell script, it's exactly what I did earlier, curling the script and piping it into SH. For the PowerShell one, it's the PowerShell equivalent, invoke web request into invoke expression, right? That's all you need to get started there. For those of you who want to dive a little bit deeper, there's a link to the .NET Up design spec that we created several months ago and have been iterating on as we add new features. If you have feedback about the tool, the appropriate place for it is at this link, .NETup/feedback. That will take you to the discussion board on the .NET SDK repo in a special category just for .NET Up that I and the rest of the team will be interacting with on. And then finally, all of the samples that I showed in the demo today, as well as GitHub actions that automatically hook up .NET Up and do the things that I was doing today, can be found at this sample repo I made, github.com/barenfell/.NETup repo patterns demo. So everything I did, you can git clone this repo and get started and try yourself. We'd love you to get the tool, try it on the samples, try it on your repo. Let us know what you think of it. Does it flow well? Is it performant enough? Does it have the features that you want? Let us know at the feedback link, and thank you so much for watching. Have a great rest of the time at Build, and happy hacking.